I want to take the derivative of the natural log function. I could do it using the definition where the derivative is the limit as h goes to 0 of natural log of x plus h minus the natural log of x all over h, and see if I can work through that. I've actually seen one textbook where they do that, and I present it in a reasonably nice way. However, I want to do this thinking of the natural log function as the inverse of the exponential function and already knowing how to take the derivative of an exponential function, right? So off on the side here, I'm saying I already know that the derivative of e to the x is e to the x. Okay, I'm going to use that information to figure out this, because this is an inverse function, and we know that the derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in. So here we go. Let's try it. I'm going to exponentiate both sides. So I'm going to do e to the y equals e to the ln x. So I get e to the y equals x. Right? I'm doing this so that I can use this information. So I'm using the inverse function to solve it for x instead. Now I'm going to implicitly differentiate. I'm going to take the derivative of this side with respect to x, and I'm going to take the derivative of this side with respect to x. I like the right-hand side. Derivative of x with respect to x is 1. Now, if I take the derivative of e to the y with respect to x, I could first of all take it with respect to y. The derivative of e to the y with respect to y is just e to the y. But I don't want it with respect to y. I want it with respect to x. So the chain rule says multiply that times dy dx. I can then solve for dy dx, which is what I really wanted anyway, because I had started with y equals something. I want the derivative. And this is 1 over e to the y. We will, of course, pause right here to ponder the import of this statement, because the derivative of e to the x is e to the x. And now I have that the derivative of the natural log of x is 1 over e to the y, because the derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in. This is a completely unsatisfactory answer, though, because I didn't start off implicitly. I started off explicitly. So I don't want my answer in terms of y's. I want my answer in terms of x. So I got to go back and look at the relationship between y and x and see if I can work that in here. And actually, it looks really kind of nice because e to the y is equal to x, so that denominator already is just, it's x. So the result is, with y equal to the natural log of x, the derivative, dy dx, is equal to 1 over x. In this form, it doesn't really look like the derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in, but it does at this stage, before you substitute back in to get x's. Derivative of e to the x is e to the x. The derivative of the natural log of x is 1 over e to the y. But then make that substitution back to x's, and you get the function of x. All right. One thing to notice on this derivative, the natural log of x, at least for the time being, we want real valued functions, so we want outputs to be real, and so we're only allowing positive x's for the natural log. Once you allow negative x's in there, then you start getting some complex numbers, imaginary numbers, and we'll get to that someday. But the natural log function looks like this. And if you look at what the derivative should look like, I'm going to do that in red, you're starting off with these really big positive slopes, coming down to some really small negatives, well, not negative slopes, always positive slopes, but getting closer and closer to 0, that the derivative should look something like this. Right. And I notice that that's what the graph of 1 over x looks like, at least for positive x's. Right? 1 over x is actually defined for negative x's as well. It's this thing over here. But when we think of 1 over x as the derivative of the natural log function, we're really only looking where the natural log is giving us real outputs. So we're only looking for positive x's. Just want to point that out.